Ah, beautiful Costa Rica, vacation paradise of Central America. Just a short plane ride from most major U.S. cities. Gorgeous beaches for the whole family, spectacular rainforests, and world-class surfing abound in this nation of 3.4 million that sits just north of Panama. Yet Costa Rica is more than a recreational haven. It's also an established major supplier of agricultural staples like coffee and bananas. But if that's the only Costa Rica you know, there's a whole other country just waiting to be discovered. Costa Rica has been a constitutional democracy with no standing army since 1949. The friendly and outgoing Costa Rican people form a highly educated workforce with an exceptional English literacy rate, especially among professionals. Costa Rica is also home to a large number of high-tech firms that appreciate its favorable exchange rate and young, vibrant workers. SAWTECK was one of the first major U.S. firms to discover Costa Rica in 1996. What started as a small 40-person assembly operation in San Jose's Ultra Park Free Trade Zone has grown dramatically. When the demand for worldwide wireless infrastructure and mobile phones grew exponentially in the late 1990s, SAWTECK expanded its product line and developed a full portfolio of RF and IF SAW filters for mobiles, base stations, broadband access, datacom, and many other applications. That expansion drove an increase in Costa Rican assembly capacity and ultimately led to building additional San Jose square footage. That work began in mid-1999 and was completed in the summer of 2000. Today, SAWTECK's ISO 9002 certified Costa Rican assembly operation totals 62,000 square feet, with 13,500 square feet dedicated to cleanroom operations. Assembly in Costa Rica enables SAWTECK to deliver competitively priced, state-of-the-art SAW devices to a worldwide clientele that indeed represents a who's who list of major wireless and datacom original equipment providers. The SAW devices assembled in San Jose begin their journey to end users with wafer fabrication in Orlando, Florida. These processed wafers are shipped by air freight to San Jose, arriving regularly in containers just like these. SAWTECK's Costa Rica facility is strategically located just minutes from San Jose's new international airport in the Metro Free Trade Zone. When wafers arrive at SAWTECK SA, they're carefully unloaded and moved into the prep area for SAWTECK's state-of-the-art, high-capacity automated assembly. The wafer SAW process begins with a simple mounting stage. Then, fully automated precision diamond-embedded resinoid blades slice the wafer into hundreds or thousands of individual SAW die. As RF and IF devices steadily shrink to meet the ever-decreasing size parameters of major original equipment providers, SAWTECK harvests more and more die from each wafer, increasing efficiency and yields across the board. Die leave the SAW room and enter our cleanroom facility, where they will shortly be placed into bases. A key to this highly efficient, fully automated process, and similar operations up and down the line, is precise measurement and alignment steps. Here, on-the-fly laser interferometry is used to ensure accurate pick-and-place operations. Boats are loaded with 3 high-speed simultaneous pickups. Next, individual die are placed into bases that are first injected with a liquid adhesive, a compound that is specially formulated for this application. SAW die are sensitive to stress, so a relatively soft silicone-based adhesive is used to absorb these stresses, virtually eliminating variations in SAW performance. Unlike consumer-grade adhesives, this compound is extremely clean and is ideally suited for high-speed dispensing. It also requires a high-temperature cure to fully set, anchoring the die permanently within its base. The curing oven is loaded with magazines of boats full of bases bearing their die. After a short cycle, the boats are removed and ready for their next stop along the line. Individual wires are attached next, bonded to precise contact points on the die and within each base. Wire bonding is unique to the manufacture of microelectronic components and integrated circuitry. A lot happens in a split second, so look quick. You're seeing 12 strands of gold wire thinner than a human hair being attached each second. That's 24 individual bond points every single second. Do the math, and you'll see that our wire bonders make literally millions of bonds each and every day. Once wire bonding is complete, SAW device covers are attached. First, a vacuum bake oven is loaded with carriers, each holding subcarriers called boats. Attaching covers is a three-step operation that picks a cover, aligns it precisely, then attaches for transport further down the line. SAWTECK's part density per boat and the boat design itself are the best in the industry, giving us the fastest throughput available. Literally thousands of devices are completed each hour. Each process has a different cycle time, which drives the number of stations that operate simultaneously, allowing SAWTECK to deliver the right number of devices at a specific moment to their next stop along the line. Once lids are picked, aligned precisely, and placed into position, parts move on to the resistant seam welder, where the hermetic seal is completed along the X and Y axes. All this work you've just seen is done in a very special environment. To create perfect conditions for hermeticity and zero corrosion of subcomponent elements such as dimetallization and wire bonds, SAWTECK assembles SAW devices in a nitrogen atmosphere with as close to zero moisture in that environment as possible. The absence of oxygen and moisture, plus the substitution of nitrogen, all within a totally sealed device, enables SAWTECK to guarantee a corrosion-free environment. So much nitrogen is used in these assembly stages that SAWTECK makes its own, thus freeing the company from dependence on outside supply lines. Once the carriers are unloaded, they leave our cleanroom environment and proceed to the leak test stage. SAWTECK's highly automated, precision-controlled adherence to uncompromising quality standards provides exceptionally high yields that help make it possible for SAWTECK to offer devices at globally competitive prices. The leak test is an essential element of our quality assurance program. Devices are bowl-fed into tracks and then multi-loaded into chambers where we test for their hermeticity. Like all automated functions, quality control testing proceeds rapidly, moving devices to the test, mark, tape and reel portion of the assembly. This rotary head machine receives devices from a bowl feeder, orients and electrically tests them. They're next rapidly placed into the reel track, laser marked, and the recessed cavities bearing devices are covered with a protective clear tape. In all, 7 different steps occur along this rapidly moving finishing stage. After packaging into reels, devices are then placed into their shipping containers, which are in turn loaded onto waiting trucks and transported by our customs expediter and contract carrier to the San Jose International Airport for delivery to original equipment producers and distributors around the world. This particular shipment is heading to Asia, where it will be part of a new mobile phone product, giving it the increased functionality today's digital devices demand. With the recent completion of SAWTECK's capacity expansion in Costa Rica, plus the addition of next-generation assembly lines geared to build flip-chip devices with surface mount packages as small as 2 by 2 millimeters, a highly automated facility of this type could have the capacity to build more than 30 million devices each month. Cost-effective, state-of-the-art assembly gives SAWTECK the competitive edge you need to be a winner in today's wireless marketplace, while it positions SAWTECK to meet the ever-increasing demands of global original equipment producers. For more information about SAWTECK's high-volume production capacity and how we can satisfy all your wireless and datacom needs, visit our website at www.sawteck.com or call us today at 407-886-8860.